Welcome to this lesson where we're going to discuss 45, 45, 90 triangles. Before we begin, make sure you have your notebook, make sure you have a pencil, and the worksheet associated with this assignment printed off. In a 45, 45, 90 triangle, we identify these sides of the triangle. So the sides where the right angle it meets, these are what we call the legs in a right triangle. And in a 45, 45, 90 triangle, because the angles are the same, that means the opposite sides are exactly the same. So because we have two angles that are the same, we're going to have two sides that are going to be exactly the same in length. This side right here, that is opposite the 90-degree angle, you'll remember we call this the hypotenuse. Now, if you have a hard time remembering right triangles, I highly suggest you pause and make sure you have this diagram written down. In a 45, 45, 90 triangle, we have special lengths for our sides of this triangle. They're meant to help you solve for these triangles a little bit more efficiently. If we have the diagram in front of us to try to solve problems, the legs are going to be exactly the same, and we represent that with an X. And the hypotenuse is always whatever the leg is times the square root of 2. Now we also have some equations that we like to come up with. So if we were missing the legs, but we were told what the hypotenuse is, the equation to find the leg is equal to 1/2 times the hypotenuse times the square root of 2. So in a problem where we're given the hypotenuse but we don't know the leg, we could plug the hypotenuse into this equation to solve. The equation to find the hypotenuse is going to be equal to the leg times the square root of 2. Now again, we're going to dive into some problems from your assignment. Be sure that you have this assignment printed off because I'm going to go over problems 1, 2, 5, 6, and 13. Each representing a problem that is similar to others throughout this worksheet. Let's dive in and start with number 1. It says, to find the missing links, leave your answers as radicals in simplest form. I highly recommend that we have our diagram and our equations, like I've written on the right side of this page, have them in a nice visible spot for you as you work through these problems. In number 1, the 5 we're given represents the length of a leg. In a 45, 45, 90, we know that the legs are the exact same number. So that means this y is going to be 5. Call this an isosceles right triangle. Two sides are the same. To find the hypotenuse, we can look at the diagram, see how it's x times the square root of 2. Well, in this diagram, our x's represent the legs. Our legs in number 1 are equal to 5, so the hypotenuse must be 5 times the square root of 2. We could have found that using our formula as well. Remember, it's the leg times the square root of 2. The leg is equal to 5, so the hypotenuse must be 5 times the square root of 2. Number 2. In this example, we're given the same leg. However, it looks a little bit different. This leg is 8 times the square root of 2. When we're given the leg, it makes finding this leg very easy because it is the exact same thing. So y is going to be equal to 8 times the square root of 2. We can either look at our diagram or look at our equations. In the diagram, to find the hypotenuse, it's x times the square root of 2. So it's a leg times the square root of 2. So if we're trying to find the hypotenuse, the leg is 8 times the square root of 2. And we need to multiply that by the square root of 2. And now we need to simplify. When we multiply the square root of 2 times the square root of 2, we can multiply the numbers underneath the square root. And this would become 8 times the square root of 4. And the square root of 4 is 2. And so our hypotenuse here is equal to 16. So you can put x equal to 16, that's what this side unknown is represented as, or you could tell me the hypotenuse equals 16. Number 5, very similar to the last one. We're given that a leg is 10 times the square root of 2. That means this leg is going to be the exact same as 10 times the square root of 2. We're trying to find the hypotenuse. So we can represent the hypotenuse with x, or we could say h. So the hypotenuse is the leg times the square root of 2. The leg of this triangle is 10 times the square root of 2. And if we're going to multiply it by the square root of 2 again, we can follow that same step. So this is the same as the previous problem. We're going to get 10 times the square root of 4. Take the square root of 4, that equals 2. And the hypotenuse is equal to 20. Okay, we're going to mix it up a little bit in our next example. In number 6, we are given the hypotenuse. And the hypotenuse is 9 times the square root of 2. Now, if I look to the diagram, notice how the hypotenuse is always some number times the square root of 2. If I isolate that number in our example, what is that number? That number is 9. So that means the legs would each have to equal 9. So take notice, when you're given the hypotenuse and it has a square root of 2 in it, it makes your life so much easier. The legs are going to be equal to whatever number is in front. Number 13. This time we're given the hypotenuse, but it's not in the form with our square root of 2. So this, what we used last time doesn't apply here. In order to find the legs, I'm going to want to use this formula. So to find the leg of the triangle, it's equal to 1/2 times the hypotenuse h. In our problem here, the hypotenuse is 15. And we times the square root of 2. So the leg equals half of 15, 7.5 times the square root of 2. So that means x is going to equal 7.5 times the square root of 2, and y is going to equal 7.5 times the square root of 2.